In this lesson, I will talk about the concept of functions and relations. Mathematically, we define a relation to be a set of ordered pairs x, y. If you think about the word relation just in everyday life, you might think of a relationship between two people, or the fact that you're related to someone, or maybe a cause and effect relationship, such as the number of hours that I study is going to determine the grade I make on a test, or the number of classes I enroll in is going to determine my tuition. A relation is simply a correspondence between two quantities. The set of x values in these ordered pairs is called the domain of the relation, and the set of y values in the ordered pairs is called the range of the relation. There are going to be 4 different ways that a relation can be represented. It can be represented in a numerical way, and that will typically be given to us in the form of a set of ordered pairs, or a table of 2 values showing their correspondence. An algebraic representation will be given to us in the form of an equation. Graphical representation is simply that, a graph showing the correspondence. And then a verbal representation will be where we have some words that are describing the relationship. But from all of these different types of relations and the representations, we can come up with a set of ordered pairs. Let's suppose that I tell you that X is the set of students in this class, and Y is the state that they were born. From that, I could create a set of ordered pairs. Right, for every student in the class, I could say the state that they're born. I'm not a student, but I'll put myself in here. Andrea was born in Florida. I'm not sure where everybody else was born, but let's say Jana was born in Georgia. Alan was born in Tennessee. Melody was born in Illinois. And so on. Now it could be that in a relation that I've defined here, that my y values may repeat, right? There's nothing to say that two people can't be born in the same state. But a relation is just simply a correspondence between two quantities. The most important concept that you're going to learn, I dare say, in this course is this concept of a function. A function in mathematics is a relation, but it's a special type of relation. It's a relation in which each value of x corresponds to exactly one value of y. So for every x in the domain, there can be only one value of y that it corresponds to. The way I think about this is that it has to be a working relation. Or if you even want to think of it in terms of a working relationship between two people that are married, right? The only way that marriage is going to work is if one person is related to only one person, right? Otherwise, it gets into trouble. Another way to think of it as your input and output. So if you think about the value of x as being an input, the value of y as being an output, let's say for instance that we input a 900 number or a Panther ID number. For that to be a working relation, there should only be one student that corresponds to that. If I put in a 900 number and I get more than one student, then that's not going to be a working relation. So what would not be a working relation? I mean, I know I've talked about some things just in real life, but more specifically, let's say that my x value is a parent and the y value is the child. If I input a parent, will it be just one child that they correspond to, or could it be more? Like in my case, I have 3 boys, so I would correspond to Andy, Charlie, and Corey. So this is a case where it would not be a function, because for that value of x in the domain, there are 3 different values of y in the range, so that's not a function. Now if I said the child first and the mom, and again let's just think about biological mom right now, would that be a function? Yes, because for every input of a child, there's only one biological mom. So that would be the case of a function. In the examples that we're going to do now, we're going to look at different relations and we're going to determine if they are functions. The first is a set of ordered pairs 2, 3, 2, 4, 3, 5. So for this to be a function, remember our rule that every input of x has only one output. So from this set, if I input the value of 2, I can either get 3 or 4. My input of 3, I only get one value, which is 5. So this is not a function. It contradicts the definition, because that value of 2 has 2 different outputs. In the second example, I have the set of ordered pairs 1, 3, 2, 3, and 3, 5. So thinking about what output values does each x value correspond to, I have an input value of 1, 2, and 3. What do they correspond to? Well, 1 corresponds to 3, 2 corresponds to 3, and 3 corresponds to 5. So every value of x has only one value of y that it corresponds to, so this is a function. Example 3 is to determine if this relation defines a function of x. We have a mapping drawn, so in the values of x we have -2, 6, and pi. And in the y values we also have -2, 6, and pi. And each value of x is mapped to its identical value in y. So thinking about those as ordered pairs, -2, -2, 6, 6, and pi corresponds to pi. So within this relation, this is a function because each value of x corresponds to only one y value. In example 4, we're given the equation y equals 2x plus 6, so an algebraic relation. To determine if this is a function, we think about this. For every value of x that we input, how many y values will we get from that? But this is just a graph of a line, right? A linear equation. Every value of x that we input, we're only going to get one y value. And so this is a function. If we look at y equals 2x squared plus 6, again, if we think about plugging in values for x, how many y values will we get? If we plug in -1, 2 times -1 squared, plus 6 is really 2 times 1 plus 6, or 8. We plug in 1, we'll get the same value, 2 times 1 squared plus 6, which is also 8. We plug in 0, 2 times 0 squared plus 6 is 6. But notice that for every value of x, I'm getting only one value of y. So this also is a function. My next equation, number 6, is x equals 7 minus y. So to determine if y is a function of x, we're going to solve this equation for y. Notice that we can take the y to the left by adding it and then subtract the x from each side to get y is equal to the opposite of x plus 7. Well, again, this is a linear relationship, which is a function. Every value of x will have only one output for y, and so that is a function. Number 7 is the example x equals 7 minus y squared. So if I solve this one for y, I'm going to add y squared to the left. So I get y squared equals 7 minus x. But to solve for y, I get plus or minus the square root of 7 minus x. So here, no matter what value I put in for x, I'm going to get a positive and negative value for y. And so that's going to tell me that each x will have two y values, so this is not a function. Number 8, x equals 7 minus y cubed. Very similar to the rest, so if I add the y cubed to each side, subtract the x, I get y cubed equals 7 minus x. So y is the cube root of 7 minus x. But each number has only one cube root, so this will be a function. Every x value has only one y value that it corresponds to. You will also need to be able to determine from a graph if that graph represents a function. So for a graph, we say that a graph defines y as a function of x if no vertical line intersects a graph in more than one point. This is called the vertical line test. So I'll explain this as we go through this example. We have a circle that is drawn here, and we're trying to think about, does this describe the graph of a function? So remember, our definition of a function is that for every x, there can be only one value of y that it corresponds to. And so if we think about drawing a vertical line through this graph, notice that the vertical line that I've drawn through this graph touches my graph in 2 points. Well, the reason why we do a vertical line is because that vertical line represents all the values on that graph that have this particular x value. And so I've selected this value of x equal 1. And I go through my graph and I see that there's 2 points where my graph coincides with this vertical line. I'm just going to estimate here. This is x and -6 almost, or I should say 1, -6. 1 and a little bit less than 0, I'll say -0.1, right? But here's a value of x that has more than one y value, so this is not going to be a function because the graph of this vertical line touches my graph in more than one point. In number 10, I have this other graph. It looks like part of a parabola and part of a line. We'll talk about those more in detail as we go through the course. But if I draw a vertical line anywhere on the graph, notice that every vertical line is going to only touch my graph in one point. And so this is a function because each value of x corresponds to only one y value. And in number 11, I have another example where I have two pieces to my graph. But notice that if I draw a vertical line through 0, I have two closed circles at those endpoints of those pieces. And so this is a place where the graph crosses more than one point. And so this would not be a function. This concludes the lesson on relations and functions. So just remember that a relation is a set of ordered pairs that is some correspondence between two quantities. There's really nothing special about that relationship. And then a function is a special type of relation in which every value of x has only one y value that it corresponds to.